Right now, there is a radiation storm that is slamming into the Earth as relativistic ions have blasted off from the sun from the magnetically conjugate point, and they are now spiraling through the solar wind to hit the Earth. And this is supercharging the Earth because these relativistic ions, they are able to flow down and kind of cut through magnetic fields a lot easier than other slower solar ions like you get from a solar storm. And therefore, they can directly enter into the atmosphere, charge up the ionosphere to a very high degree. And there's a lot of long-term, you could say, longer than just like 2 days or 3 days, geophysical effects to this. The immediate geophysical effect is that we can have changes to the ionosphere, and this can cause, for example, shortwave radio blackouts and other things, GPS disturbances and more. But there's also these stronger to alert currents that are generated, and overall the Earth energies get amplified. And what's interesting about this proton radiation storm, we're going to look at all the data, is that it is launching from this sunspot group that's rotating off 3990. But we have a new, really big sunspot group that's been growing over the past 24 hours, already large, getting larger, that will soon be basically in the same spot. And so we already had one wave of solar protons hit us, and now this new one has bumped it over the S1 threshold, and then perhaps this guy also triggers, and that will be occurring. If that doesn't happen, that will be here right as these coronal holes are Earth center direct geoeffective, a little bit past that actual center line right there. And so we could be hit with, let's say, a proton storm from this, and also coronal hole high-speed streams from that. And we're also having more flare activity. Sunspots are coiling up. Maybe they're about to break upwards. Let's look at all the data in today's video. Let us start with our 131 angstrom view, just so we can see this solar flare and coronal mass ejection. It's pretty wild. That was a 2.0 X-class flare. That occurred yesterday. This data is for February 23rd and the 24th. We've had some other activity as well. You can see this sunspot group being quite active, this guy right there. But at the very end of the video, you'll see this coronal mass ejection launch, boom, and then look at that long duration flare afterwards. So a really big coronal mass ejection launched just hours ago. That is now rippling out through the solar system. That shock wave, part of that looks like it's going to hit us because we already have been hit with these relativistic ions. But we'll look at the chronograph imagery. It does appear that there's a slight halo component to that. And that's possible. With these coronal mass ejections this large, you can have, even from the limb, part of that still go out and interact with the Earth. So we may have a solar storm come in from that in the next, let's say, 2-3 days or so, maybe a little bit longer because it is a little bit tangent. But that is a big, big, big solar flare, coronal mass ejection, and that is what's increasing this relativistic flux on Earth. Let's quickly go to our flux so we can see what I'm talking about, because this isn't the most epic radiation storm that we've ever had in terms of what we've had before, because we haven't had a radiation storm like this for some time now. And we see this double bump. So we see this first one here, and then we see the second increase there, taking us over that S1 threshold. This is for greater than 10 mega electron volt protons. So let me get this lined up a little better right there. We have 4 different levels that we look at with this data product by NOAA. We have the greater than 10 mega electron volt, greater than 50, greater than 100, greater than 500. An electron volt is a measure of energy effectively. I have some graphics I could talk about that. Maybe we'll do that after this. But we see that our greater than 10 mega electron volt, which are the lowest energy of these 4 brackets, they have bumped up. And then with this most recent storm, the greater than 50 has also bumped up. But you'll notice that the greater than 100, greater than 500 has stayed flat. And you need those to go up to have something like a ground level enhancement typically. So you won't get an enhancement of ions raining down directly at the surface unless you get these guys to really go up, because they can create these particle showers that actually cascade all the way down. So this is mostly interacting at the level of the ionosphere and the upper atmosphere. I mean, certainly some of these come down because they just don't have that probabilistic interaction with something. but the overall flux at the surface is still, you could say, fairly normal. But in general, this energy eventually does reach down deeper into the Earth, because when you have stronger electric currents in the ionosphere, you generate stronger telluric currents in the subsurface and in the oceans. And then that changes things. And so there's a ripple effect that comes out from all this. And right now at the beginning of that, we had a little bit of a preview phase. If we look at our actual numbers here, this is a log scale. So it can be a little deceiving if you're not used to looking at log scales versus linear scales. But our greater than 10 mega electron volt protons are at 30 right now. Normal values are right about here, 0.15, 0.2. So let's take 0.2. That is a 60x increase, right? Dramatic increase in proton flux. Yeah, so I mean, we're nearly at a 100x increase for greater than 10 mega electron volt protons. We can also look at our real-time absorption map to get a sense of what's happening. We see just a lot happening with this graphic here. And I'll punch in. We see that our normal D region absorption is enhanced during flares like that one we saw there. This is the daylight side of the Earth. But then when we have this sort of proton storm come in, it really gets funneled to the polar regions, because that's the magnetic field guiding those ions down the magnetic field. And then they put in, the fact that we are in a proton radiation storm, and look at how quickly that attenuation went up. Our highest frequencies being absorbed by 35 plus decibels, really hitting the southern hemisphere, because the Earth is tilted more right now with southern hemisphere than the northern hemisphere. But we have equinox coming up soon. And in fact, because we're further away from solstice than we are closer to equinox, we have greater swings in the ionosphere occurring at this moment in time. So because as the tilt angle of the Earth is changing, there's greater flux with the ionosphere itself because of the changing light budget, you could say, for the Earth. So yeah, we have this already occurring, and we have in general this sort of impact coming on top of already enhanced ionospheric volatility that will continue through March and into April until it kind of cools off with the next solstice in June. We have our X-ray flux. We can see this kind of more directly, these solar flares and such. This is for the past 7 days. And this is a long duration flare that occurred too. They are more likely to cause these sort of effects. And so here we see things ramping back up on the 21st. Solar activity is fairly quiet. We were in a bit of a lull period. We got this bump up, and then I released my video here saying solar upsurge beginning with that flare right there. It occurred right as I released my video. And then we had the X flare, and now we had this radiation storm. So I do my best to kind of look forward a little bit with solar activity, anticipate what's about to happen, not just be reactive. And, I gave you the update right there as to there's going to be an upsurge in solar activity, and boom, now we have this S1 radiation storm, long duration solar flare, X flare, more M flares. So a lot happening at this moment in time. Let us look at our sunspots, because we have this flare that just occurred, and we had that proton storm because it came in from the western limb. This is solar coordinate system, so it's kind of flipped from what you would think it is. But this occurred from right over here, and that's because that part of the solar wind naturally connects to the Earth. So it's really easy for these relativistic ions to flow down the solar wind magnetic field and hit the Earth. But you can get radiation storms from an explosion also on the far side, or from really anywhere. But it'll have to be stronger because they'll be cutting more across the solar field. So you can have them happen easier, you could say, from this zone. But we have this sunspot group right there, soon to enter into that zone. Also, this guy up top too. Like we had that 2.0 X-class flare from the northern hemisphere on the western limb. But watch here, this has been growing just over the past 24 hours. See that right there, push out in the center? It's just become bigger and meaner looking. And it's already a big sunspot. We did have a reduction in the size of this core right there. But in general, this sunspot group, I'd say, looks more compact, consolidated, and unstable as a result. We've been seeing it kind of popping and sparking already. So Yeah, it's that will soon be in that same location. And kind of what we're seeing is that when all these sunspots are on the Earth facing side, they've been quiet. This is like the past 2 weeks I'm talking about. They've been quiet, and then they got active right as they reached the limb. Why? That's like a good question. But if that trend holds, which it has been, then these guys will start flaring as they reach the western limb. Not guaranteed, but that has just been the trend that we've been seeing over the past, let's say, a week or so. So that is something to be aware of. We can also look at let's look at our 304 angstrom view of the sun. This will show us any sort of plasma filaments that have launched and prominence eruptions and things of this nature. And one thing you will, or rather you won't notice, is that this really didn't show up on 304, this big long duration M-class flare with the high-speed coronal mass ejection. You barely see it there at the end. And this is the lowest temperature Kelvin view of the sun. It basically shows us darker plasma a little bit easier than higher energy, higher temperature plasma. And so the fact that that didn't really show up on the 304 angstrom view shows you that this flare was consisting of the most highly energetic plasma of the sun. We saw it very nicely on the 131 angstrom view. That is of the highest temperature plasma. That's like 10 million Kelvin or so. This is 50,000 Kelvin. And so that was a very energetic event that just occurred on the sun, creating that shock wave. Let us actually look at that now, because this is really quite incredible. If we look at our CCOR1 data, this is awesome. So let me pull this up. Here's our preliminary CCOR1 chronograph. Check that out. That is from that coronal mass ejection. So you have a solar flare, it pushed out the coronal mass ejection, and that just really quickly propagated outwards. But you'll notice some push out here on the left side as well. But honestly, it doesn't show up this well on the CCR1. We'll look at also our SDO chronograph. You'll notice the coronal mass ejection that launched from that 2.0 X-class flare in this data as well. So 1, 2, will we get a third? That's a good question. Let's swap over now to our C3 chronograph view, because we can see that shock wave that's Earth directed a little bit better with that one. And we can get this started up. Here we're looking at our SDO chronograph. There's that 2.0, and then we will see this really big coronal mass ejection launch. Look at that. But let me play with the slider here specifically for you. You will see this shock wave come out. So we go here. Oh, I'm grabbing the wrong screen. Okay, so we go here, and then just like that. You'll notice a push. Maybe I can do the mouse with my left hand, perhaps. You'll notice a push right here at the end. It's not that strong. It's fairly faint, but that was a big enough explosion to kind of just in general create a shock wave. And so it'll be interesting to see how that impacts us. Of course, we're already getting some of those impacts from that relativistic flux, this radiation storm. But it'll be interesting to see if there's anything else that comes in from that. Here we have our sunspot numbers, and for the past 30 days or so, and let's leave it right there. I just want to show you this because there's just a really interesting pattern that's emerging. Whereas before we had this really regular 28-day periodicity, basically, based on the solar rotation, but there has been a shift over the past just 2 weeks or so, where that frequency has changed. The regular solar rhythm has altered. And so we've been having, kind of like this limit of about 180, 190 sunspots. Then we had a lower high or a higher low right here. And then we had another higher low right there. Sunspot numbers are almost 150 for the month of February. Thank you, Tony, for the super thanks. And we just recently came back up off of that. And so we had these sunspots about to rotate off, but at the same time, it looks like we're about to just break through it. We don't know. Depends on what rotates now and what opens up on the sun over the next few days. But the sunspot numbers are really interesting. Look at these rhythmic trends. I think honestly it's going to break down with these sunspot groups rotating out, but we could have a big explosion of flux on the sun that takes sunspot numbers either maintains them or takes them even higher. It's possible. We'll just have to watch to see what happens. But I find this change in the periodicity the most interesting thing because it's showing some changing dynamic with the sun. And this is related to solar maximum, the flip of the magnetic field. We were having more flux now in the northern hemisphere. We've had a lot of flux in the southern hemisphere back in 2024, 2023. It was southern hemisphere dominant. Now we're seeing more sunspots in the northern hemisphere, signaling some sort of state change with the sun as it's going through its solar cycle and through solar maximum. We're in 2025. And so I just think this is kind of a little bit of a preview perhaps what we have coming our way, just more volatility in general with the sun. We can also look at our ACE real-time solar wind, just so we can see the fact that we've actually been having elevated counts of lower energy protons for a while now. We see that right here. And this is starting back on the 21st, they jumped up. So they jumped up pretty quickly with that initial increase in solar activity. These are lower energy. So we can see their kiloelectron volt levels here. These are all the kiloelectron volt range. But we notice that they've jumped up and basically have stayed up. This is also a log scale, so they have declined slightly since the 23rd there, but they're in general elevated over normal. So we have this more highly energetic proton radiation storm that's occurring right now. We also have more higher energy protons, though in the kiloelectron volt range, streaming into the planet at this moment in time via the solar wind. And let us look at, let me pull this up. Let's look at our 193 angstrom view of the sun so we can see these coronal holes in action. Here we have our 193 angstrom view of the sun, and we see these big coronal holes there. I talked about them briefly earlier, but we see them better with just the default 193, and they are going to be lined up here Earth center, and they don't go geoeffective until they pass through that zone. Notice all the solar activity we have following behind them. A lot of active regions following behind these coronal holes, which have been on the sun for a while now, multiple rotations. And so once they're actually slightly past that Earth center, they're entering into a geoeffective position right here. This is when that sunspot group will be right here. Perhaps we get, again, as I mentioned earlier, another proton storm from a big explosion there, just based on the trend of recent flaring. And we have all these guys then, which will be firmly on the Earth-facing side, and perhaps they start popping off. Historically, in this solar cycle, we've had a ton of flares from this region right there in the southern hemisphere. So that's also something to consider. These are all just possibilities I'm laying out, but these coronal holes aren't just going to evaporate instantly. This guy has been there for a while, so we know that we're going to have some high-speed streams enhance the solar wind over the next week. As it relates to the rest of this, we just play with probabilities and what could happen. But with it being solar maximum, generally, I myself err a little bit more on the side of greater volatility and energy rather than less, especially now that we're seeing this frequency shift with the sun and we're coming out of the solar doldrums, it seems. And I think that's going to continue in March and April and perhaps even into May. But that's just my intuition. I want to make sure there's nothing else that I'm missing here. This is just a quick update for you all. And yeah, thank you all so much for being here. Let's punch in on that sunspot group in particular, the one that we looked at, because it would be good to really kind of go in detail on it just for a moment. So let's do that. And we have our 4K magnetogram here. We go back to here, and here we have our sun as it is right now. We're looking at the intensity of it. So basically the sunspots, we see this guy up there actually has been growing quite a bit, but still not in the big leagues. You know, it's still a softball player. But this guy, I think, has just entered into the big leagues for sure. And so we see it's compact, a lot of cores. This has been what's responsible for most of that sunspot growth over the past day, I would say, because more of them have opened up. So yeah, and perhaps you've been feeling this solar activity, headaches, blood pressure. I mean, I had my bloody nose yesterday, though there's some other factors with that as well. I think it's because it's too much to explain this video, but these sort of changes in solar activity can alter kind of your autonomic nervous system, and therefore they can skew you more sympathetic and take you away from parasympathetic activity. That is why, for example, I'm drinking Spirituality, which is on the website, wildfreeorganic.com, because this is fantastic for enhancing your parasympathetic nervous system and for working with these energies in a more balanced, harmonious way. Mugwort, chamomile, lotus flower, passion flower. It's the best combination out there. Thank you, the Tarot. We have Drunken Tarot and Lunatic Astrology. Thank you so much for the super thanks. Lunatic, I watch your channel, so thank you for the videos that you do as well. That's awesome to see you here. You do fantastic work. Now, Drunken Tarot said, can you talk about any planet correctly later once this week, like the amazing new moon on Thursday? Yeah, I'm going to be doing an update on April and March. And we already have the planetary lineup. So if you haven't seen that video, go watch my video on the planetary lineup for the 28th, because I do touch on the moon. I probably won't do a new moon forecast though. There's so many people, like wonderful astrologers like Lunatic Astrology who does this sort of video. So go to her channel and watch her new moon update. I'm sure it's fantastic. I haven't watched it yet if she's put out one, but I would send people her way. So yeah, she's doing amazing work as well. So yeah, this is the sunspot that we have that I'm kind of looking at closely. But right now, let's just go back. We have this proton radiation storm that we are in, greater than 10 mega electron volt protons. They are up about 60 times over normal. Greater than 50, looks like it is up about 2x. So you can see the change there. And I mentioned that we were going to talk about electron volt briefly, because these live streams are also more than just informational in terms of what's happening. They are also educational. So let's learn about what an electron volt is. An electron volt, 1 electron volt, is the energy gained or lost by an electron or proton moving through a voltage difference of 1 volt. So an electron moves through a voltage difference of, let's say, 4 volts. It's now 14 electron volts. Goes through 7 volts, it's now 17 electron volts. And so when you go to kilo, that's 1,000, and you go to mega, that's 1,000,000. So we're talking about a lot of volts here, right? Or it can go down. And so it has to go through this voltage gradient. So when you have a big explosion on the sun, you have this extremely powerful voltage gradient that's there right at the surface that these ions are pushed through from that magnetic field. And as a result, they then enter into those kilo and mega electron volt ranges. So we have an electron gradient here on Earth. The surface is 0. The ionosphere is 250,000 volts. For an ion to go from, or a particle, let's say proton, to go from the surface to the ionosphere, it has to go up to that rough level because it's going through that electric field gradient, right? But with the sun, it's millions of volts, basically. So really, really powerful. We have an air molecule at sea level, 0.03 electron volts. A visible light photon has an electron volt rating of about 1.5 to 3.5, depends on the wavelength. The average molecular bond is 1 to 10 electron volts. So once you're over 10 electron volts, you can break that bond. An electron in the polar aurora is like 1,000 to 15,000 electron volts. This would be 15 kilo electron volts. The electrons at Earth's ring orbit, 50,000 electron volts. The range for solar wind, kilo electron volt to mega electron volt. And then you go up higher and higher. You even have electrons, let's say, streaming in from Jupiter. They can go all the way to 30 plus mega electron volts. That occurs in a pulse once every 11 months or so. And then you have even giga electron volts. That's possible as well from solar explosions, but really big ones. And then you have even beyond that as you go into cosmic radiation, it gets insane. So yeah, there's some data here that you can read. You can pause the screen if you want to read that. But that is the electron volt. And so that gives us a bit of a sense of the scale as to these relativistic particles that are flowing in from the sun right now. They are very, very powerful. Celestial Cheerleader, thank you so much for the super thanks. I like the name too. So thank you for being here. And that is basically it for today. Just wanted to kind of go through all this for you all. just to give you a heads up as to what is happening. I'll keep you up to date as to what is occurring energetically here on Earth and also with the sun, the solar system, the cosmos. We look at all these things. I take in a bunch of different modalities. We look at space weather from a very clear scientific perspective, but we also look at things like planetary geometry and different energy rhythms of the cosmos. So if you like to learn all that along the way as well, that's the other benefit of subscribing, then please subscribe, smash that like button. And again, yeah, I would just recommend personally that if you are feeling any sort of energy flux from all of this and you're feeling just a little bit discombobulated, you could say, then spirituality is great. Again, really good for your nervous system and it increases your parasympathetic activity, which most people are deficient in. Rest when you need to, and then earthing and grounding. So go outside, go barefoot, connect with nature. That's the best way. Even like laying out, if it's nice where you are, you can do that. We have a big heat wave coming through North America, at least. So there should be an increase in the temperatures, which makes that easier. But I also have earthing shoes available on the website wildfreeorganic.com, all natural, that help you connect these energies more in your day-to-day. So go check those out. I'll put a link in the video description. So again, thank you all so much for watching. Wishing you all well, and I'll see you all very, very soon.